The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to the Alarm Corp webinar for today. My name is Jeff Rushton and I'm the Chief Technical Officer here at Alarm Corp. So I'd certainly like to thank you for coming along, and we'll get started. Before we begin, just a little bit of housekeeping. I'd like to point out some of the features of the GoToMeeting software. You'll notice that you have all been muted at the moment. Typically throughout the course of this presentation you will remain muted. If you cannot hear or cannot see the presentation for any reason, or for any reason have a question, you can use the raise hand icon. That will alert me that that you need some form of assistance. During the course of this presentation, you're more than welcome to write down a question. During the end, or at the end of this presentation, we'll take as little or as much time as needed to go through and answer those questions. So at any time you feel you have a question, write it down and we'll attend to it at the end. Before we begin, I might just get you to use the raise hand icon just so I can see that you can see the presentation and hear me talking. Very good. If you click it again to release it, we'll get started. Okay, today we're talking about the Siemens Seismic Detectors. We'll be going through the applications, the installation, the software, and give you a chance to ask questions at the end, as I said. This particular product has been around for many years, sort of showing my age now. When I started in the security industry about 30 years ago, they were called a GM31, and by far the most popular seismic product that was available then. A number of years ago, they changed their name to the GM5 series. There was a GM530 and a GM560 detector. About 4 years ago, Siemens released a new version of that, and they're called now the 7 series. The two in question that we'll be looking at is the GM730 and the GM760. Both the GM730 and 760 are very similar in specifications, and they look identical. One of the main differences is range. As you can see, the GM730 has a range of 4 meters, which is also the radius, and the GM760 has a range or radius of 5 meters. That detector covers an area of approximately 80 square meters. You'll also notice that the GM730 is designed to work on steel, but can also work on concrete, where the GM760 is primarily used on concrete surfaces and synthetic materials, but can also be programmed to operate on steel. We'll have a look at the range now. So as I've said, this is the range. This is the minimum range. It's not the maximum range. So basically, if you install these detectors according to the installation instructions, you will happily have detection across the entire range that you've picked. The GM7 series seismics will detect all known attack methods. Some of these are thermal or oxygen lance, drilling, also water jet, and explosions. We'll have a look at the details of each of these detectors now. See the GM 730, as stated, has a 4 metre radius. The remainder of the specifications are identical for both. The SenseTech biomorph sensor is the heart of the detector, and this was developed by Siemens, and it offers exceptional false alarm immunity and is also one of only a few detectors in the world that can detect all attack types. Both detectors have digital signal analysis and a remote sensitivity control. We'll see how this works a little bit later. Both also have the ability to fit a test transmitter into its case to allow for remote testing of the sensor. The main applications for the GM730 are ATMs, night safes, and vending machines. You can also get them to work on small safes, strong rooms, and doors also. The detectors have two dip switches on the PCB, and their function is different between the two detectors. For the GM730, the switch settings are steel, high sensitivity with a 2 metre radius, steel, low sensitivity with a 1.5 metre radius, or concrete, 4 metre radius. There's also a user-defined setting, and that's controlled by the Sense Tool software, and we'll see how that works shortly. The typical selection of a GM730 used on an ATM would be steel, low sensitivity, 1.5 metre radius. By using the GM730 on an ATM and setting this switch setting, the Sense Tool software is typically not required, so therefore making your installation and setup a whole lot easier. All they need to do is mount the detector, adjust the switch settings for steel 1.5, test it, and you should find it will require no further adjustment. The GM760, as stated, has a range of 5 metre. The other features are identical, with a couple of exceptions. First exception, this detector has event memory, and that is the detector can record the last 100 alarms in its internal memory and can be viewed or exported using the Sense Tool software. This is a great tool to identify and fault find any false alarm problems. It also has adjustable temperature supervision. Now both detectors have a lower and an upper temperature that will generate an alarm. But the GM760 has the ability to change those temperature ranges. By default, the temperature range is 0 to 15 degrees C up to 85 degrees C. With a greater range, you would expect that the GM760 to be installed on larger objects. Hence, it's ideal for large safes, vaults, strong rooms, ammunition dumps, applications like that. It can also be set to work on ATMs, but will require the software, and we'll see how that works very shortly. So the two switch settings on the GM760, you can pick directly concrete 4 metre, steel 2 metre, or LSW 2 metre, and that's for a lightweight synthetic material. Further settings are available with the software, including steel, low sensitivity 1.5 metre, which was for the ATM use. But but when using a GM760 on an ATM, you will require the software in order to adjust it correctly. So just to summarise the difference between the two sensors, GM760 has an additional 1 metre of radius. It also has the ability to store 100 events in its memory, and you can adjust the temperature supervision on this device. The GM730 also has a temperature alarm, but it's fixed. The diagram on the left here shows the location of the jumpers and the dip switch settings. You'll notice at the top that there is a mini USB connection. That's for the software. When purchased, the software comes with a lead that's got a mini USB on one end and a 9-pin serial connector on the other. If you don't have a serial port on your PC, just buy a commercial USB to serial converter, and most of those should happily work for you. Towards the left of here, there is a connection for a GM XD7. That's an optional drill tampered lid for the Seismics. So in some applications where you're worried about people drilling into the lid of the Seismic to gain access to the switches or the cabling, you would replace the lid and put the GM-XD7 on. Below that, there is a set of connections for a GM-XS1. This is the optional test transmitter, and that allows you to remotely activate test mode and generate an alarm within the Seismic to ensure that it's operating correctly. It's pretty much mandatory to have that GM-XS1 when using them in a financial market. There is, next to that, an LED. It just shows alarm and will glow red on alarm. Up on the top right, there is the two-way dip switch that allows you to pick one of 3 modes or a user mode. And that user mode is programmed via the software, which is coming up on the next couple of slides. On the right, you'll see the wiring connections. Typically your 12-volt input, tamper, alarm relay. You've got 2 other inputs here, test input and remote. Test input enables you to remotely activate that test transmitter to generate an alarm. The remote enables you to reduce the sensitivity of the detector by about a value of 1/8 its normal sensitivity. Why would you want a function like that? You may have, let's say in a bank, where the cleaners are on site. You don't want to disable the alarm, you just want to make it a little bit less sensitive while they're cleaning. Or potentially in an ATM, when they replace the cash drawer. Again, you don't necessarily want to disable the alarm system, you just want to reduce the sensitivity while they have the door open and replacing the cash drawer. The installation manual for these detectors is a valuable resource with examples of all of the features that the detector has. The table that you're seeing shows what sensitivity is required for the different types of safes and vaults. So it's showing the application, a ticket machine, for example, with heavy noise, steel 1 meter with a low sensitivity would be either the switch settings or the software settings that you would set the detector for. And both detectors have, as I've said, different switch settings for different environments or different applications. There's many different accessories that you can purchase for these seismics. I've got some of the more common ones listed. The GM T4 box is used to house the seismic in high security installations. This box provides greater tamper resistance, as well as it's a secure place to locate the end-of-line module. And this box is required for all Type 1 or SCEC installations. The GM XPO is a mounting plate that allows you to easily install the seismic on any other surface other than steel. So if it's going under concrete or brick, highly recommended that you install the mounting plate and then install the seismic on the plate. The GM XP3 is used on safes that have a keyhole. You notice that the unit swivels over the top of the keyhole to prevent insertion of the key. When swiveled back, it activates a tamper switch, and it's really a great alternative to, let's say, installing a reed switch on a safe or a vault door. You can put this plate behind the seismic and it will cover the hole so you can't enter your key to open the safe without setting off an alarm. The GMX S1, as I've mentioned before, this mounts inside the detector. It has its own lead and plugs directly onto the terminals onto the seismic. And the way that this works is that it emits like a cricket sound when you activate that test input, and what it does is generate a noise and a frequency onto the safe or vault or whatever surface that it's connected to, and within a number of seconds the detector should go into alarm and activate its output. Typical applications with this would be certainly most definitely in a bank, where they might have to do daily or weekly test conditions of all the detectors. So in this case, all they do is put their panel into test mode, it activates the test transmitter, puts the seismics into alarm, generates an alarm back at the panel, and then the test would be complete. If you have more than one seismic, you could use the GMX S5. It operates the same way, except mounting within the detector, mounts on the wall adjacent a number of detectors. Typically though, you find that the GMX S1 is far more cost effective, whether you have one or whether you had 100 seismics. The GM XBO is a flush mount floor box. Typically this would be installed when they're pouring the concrete for the slab, and it just enables the seismic to be flush mounted and maybe a little bit more secure and safe than it would be if it was surface mounted onto the concrete. The same way the GMX W0 is used for walls. Exactly the same way, it flush mounts the seismic within a concrete or a brick wall. The GMX C2 is just a 16mm conduit adapter that allows you to happily conduit up to the seismic to ensure a clean and neat fit. If for any reason the seismic needs to be located outdoors or in any form of adverse weather, the detector isn't weatherproof. It will require a GMX WGO, and that's a watertight housing for the detector. So if it's on the outside of a building or any place where it's likely to be splashed or covered in water, this box is essential. The GMX W7, this comes with the SenseTool software and a connection cable. As I said, there's a 9-pin serial cable on one end and a little mini USB connection on the other. Typically you would use the software to perform a variety of tasks. Some of those would be to further adjust the sensitivity beyond the level offered by the two dip switches on the PCB, potentially to select a different application. Let's say in the case of a GM760, to have it work on an ATM, you will require this software. If you wanted to change the polarity on any of the inputs or the outputs on the seismic, you require the software. If you wanted to enable or disable the temperature monitoring on either of the two seismics, you require the software. If you wanted to retrieve the 100 alarms from memory of the GM760, you can only do it with the Sense tool. And what you'll see in a second, in particular where it's good is to monitor in real time the level of noise and activity that the seismic is seeing on the surface that it's connected to. And by viewing that, you can happily make the adjustments to ensure that the seismic will operate reliably. What we're going to do now is have a look at the software. You can see the software, but you won't be able to see the setup that I have here. So I've got the Sense tool software already loaded onto my computer. I have a GM760 detector plugged in via the cable to a USB to serial converter, in my case, because I don't have a serial port on my computer. So if we run this software, I'll give you a quick rundown on how it works and how best to adjust the product. When it's run, it will always ask what COM port that the unit or the cable is connected to. In my case, it's COM port number 1. You'll notice that this won't fit directly on your screen, so I'll move it up and down to show you the full screen. I have changed the resolution on this to make it a little bit larger for you, but typically it would happily fit on anyone's PC screen. When loaded, you can see there's a lot of things grayed out currently. I have a detector connected, so if I go detector and upload, it will connect to the detector. It will immediately tell me that I have a GM760 connected. It will put it in here. If I move this up a little bit, you'll see in the bottom right hand corner that it will tell me what the current switch settings on this detector are. So dip switch settings, it says it's user mode, and we've currently got it set for concrete 4 meter, which is what it currently says on the software. If we wanted to have a look at the settings of the GM730, we could happily just change it here and view what is different between the two detectors. Obviously we can't upload or download this when we have a different detector connected, so let's just go back to this one for a moment and we'll have a look at what options that we have. You'll see that I mentioned a couple of times, if it was going on to an ATM, you would pick the option down here, steel 1.5 meter. You see the majority of these are for larger installations. The fact that the GM760 has a larger range, you would expect it to be located on a big vault, maybe, a wall, concrete, brick, Besa brick, any solid surface would do the job, steel for that matter. We would pick the corresponding application according to our instructions, and then after a bit of testing we may want to adjust the shock sensitivity. Typically it would be medium or low. Rarely would you put this detector on high sensitivity, but the only way to be sure is to test it and to be happy with both the amount of shock or amount of activity that's required in order to generate an alarm. You can see here that we can change the polarity of our test input, of our remote input polarity as well, and we can enable or disable our temperature surveillance. By default, as I said, if the temperature is lower than -15 or higher than 85 degrees C, it will generate a temperature alarm on the output. The fact that this is a GM760 means I can change that temperature in here between the limits that are shown. We'll just leave that as it is at the moment. Typically the alarm relay is normally closed. We can happily change that to normally open. Once you pick those settings, you can put in maybe some details on where that device is located and save that for future reference. In order for the detector to have these new settings, assuming that we've picked a new setting, we need to download that to the detector. Once downloaded, it will have these settings that we've picked. The criteria is that the dip switches on that detector must be set both on, which means user mode. If it was in any one of the other three possibilities, it would be the sensitivity according to the manual. So if we want to use the software, we need to ensure that it is in user mode, which ours is. If we go across to the Analyze tab, we can see now in real time, if I hit the Start button, I'll just move this up a touch, we can see two graphs, signal graph on the bottom and basically an alarm graph on the top. What I'll do with my Seismic now is I'll set it into alarm, and I'll set it into alarm initially. You can probably hear it in the microphone. I want to set the scale on the graph correctly so we can see exactly what it looks like in real time. So with no activity, I've just got this Seismic sitting currently on my wooden desk. I've just placed it back down. We can see the bottom bar, the blue bar, that really is showing the level of noise in its ambient condition. That really should be exactly like it is, a flat bar. If there was any activity on this at all, and I'll create some activity, you'll see various spikes come up. If I hit the sensor, you'll see larger spikes. When you have a look at the red graph at the top, that's indicating to us how close to an alarm that the detector is in. In other words, when the sensor gets to about 280, 290 on this graph, it will generate an alarm output. If we, let's say, use my screwdriver on the size of this Seismic to generate some activity, you'll see that the red line is growing slowly over time. Hasn't gone into alarm yet, but it's getting probably 2/3 of the way there. If I stop any activity on that Seismic, you'll see that the blue bar is flat, but the red is slowly dropping down. It doesn't drop immediately. And then over a period of a number of seconds goes back to its normal state. I'll just continue drilling, let's say, the side of this detector until it goes into alarm. You'll see over time that's going to rise again and again till it goes into alarm, then immediately resets, and then is ready to generate another alarm. Whether you're setting this up initially for the first time, or whether you're there because for some reason the unit happens to be false alarming, this is a perfect tool to sit there for whether it be a few minutes or 10 or 20 minutes to view what's happening on this detector. And by doing a number of tests, it might be a real world test by the customer or the client wants to drill into his vault, or he just may want to tap the side of the thing with a hammer a few times, or in my case using my screwdriver to test the sensor. You can see what sort of activity it takes in order to generate an alarm on this product. When we're finished with this, we need to hit the stop button, otherwise we can't do any of the other functions. There was one more tab here, Event Memory. By uploading the event memory, being a 760, we can view the last 100 events. This has only just been recently powered up, so you'll see that there's only half a dozen or so alarms here. Date, time, and the type of alarm. An integration alarm is Siemens terminology for an alarm that's generated from multiple things. So in the case of me scratching the side of the detector, it's from the potential for drilling, for shock. So when it involves more than one type of attack, it will generally say integration. If it was temperature, it would say temperature. If it was shock, it would say shock. And this is a good way then to test with either your panel or your control room or wherever the alarm is going back to ensure that it was actually the seismic that generated the alarm, and it didn't, and the alarm wasn't generated for something else like, I don't know, faulty cabling, alarm panel incorrectly set up, etc. Again, only available on the 760. A very good way to ensure that the alarm came from the device. You can happily reset this. If it goes to more than 100 events, it will write over the oldest event, and you can happily save this off to a report as well if need be. The same with the analysis. We can save this and it will list in numbers the signal and the integration alarm. If we wanted to leave this connected for a longer period of time, we can happily change the setting here, and we could leave this connected overnight if we really wanted to, and it would work over an 18-hour period in this case. Once we're happy with our setting and our sensitivity and it's all been adjusted and set up correctly, before we exit, I would always recommend that you download to the detector again just in case something has changed. Then once it's done that, you are happy to exit the program. What we've got going, and we'll discuss our seismics a little bit more after this, but what we have as, I suppose, incentive or whatever for you guys coming along and viewing our presentation is when you log on and create an account on our website, we will set up an account, set up a discount structure for you, which you can log in and view products, download manuals, order the product, or see your pricing. We're also giving an additional 10% off anything that you purchase on your first e-commerce order during the course of the remainder of this month. Just go to alarmcorp.com.au and follow the prompts to create an account. If you'd like to know more on this or any of our products, they're all located at alarmcorp.com.au. You can contact your nearest Alarm Corp rep. We've got Ed Savaris up in Queensland, Bob Graham in New South Wales, and Steve Dinger in Victoria and the Southern States. Or you can happily contact myself directly as well. Or call in and visit any of our offices. Currently we have 3 branches, all on the eastern seaboard: Melbourne, Mount Waverley, Yagoona, and Bowen Hills. Feel free at any time to drop in. In short, this completes our webinar. I have noticed a couple of questions come in, so I'll go through and answer those now. But maybe just before that is, as I've sort of described, this product has been around for many, many years. Alarm Corp is the exclusive distributor of all of the Siemens intrusion and CCTV products and access control products in Australia. The GM7 series seismics are by far the most popular product of its type that is available, and just about every ATM in the country would have at least one of our seismics installed, and the vast majority of high security sites that require ram raid or drilling or explosion protection would also have a number of these products located on the walls, ceilings and floors of the buildings in question. One of the questions, funnily enough, that came through is in relation to our SCEC approval or endorsement of these products. As I've described, the GM 730 and GM 760 have an optional box. It's called a GM T4 box. If you're installing anything for a Type 1 system, in order to get its highest approval, and the highest security level available is a security level 4, the GM 730 meets a security level 4 when installed in one of our boxes. If you do not install it in our box, or install it in a box that you've made up, the best it can meet is security level 2. A question that's come through that I should answer is, do I change the switch settings back after using the software? The answer is yes or no. If you want to use the settings that you've changed within the software, you must have the switch settings in user mode. If you have the switch settings in anything other than user mode, it will be at the sensitivity that is preset for that particular detector. And you'll see that in the instruction manual. But no, to use the software settings, it must be in user mode. Another question, do Siemens have other seismics in the range? I've been on the Siemens website and there are others available. The answer to that is yes. If you did venture across to the Siemens website, you'll find that there are 4 seismic detectors in the range. A GM 710, which is a 2-meter radius detector. That's not sold here for a couple of reasons. One, it doesn't have the necessary approvals to be sold in Australia. And 2, the price difference between that and the GM 730 is not enough in order to necessitate us having an alternate product available. There is the 730, of course, the 760, and there is a GM 775 above that. Currently, we do not bring that product into the country, but we're re-evaluating that situation, and you may find that at a later stage that may form part of our product offering. But currently, no, that product is not available in Australia. Someone's asked regarding pricing. The short answer to that is I don't want to give pricing out. Anyone that has an account with us will already have their fixed pricing. If you're a major integrator, without question, it's already within your system, within your company. But as a budget estimate for whether it be a consultant or an end user, both these detectors are not expensive at all. The dearest would be around the $300 or under the $300 mark. The smallest is less than the $200 mark. So not an expensive product at all. Is there any other questions before we wrap up for today? There are. I've just got to read them. Hang on a sec. Whatever. Someone's asked regarding a mobile handheld tester. There is no such item for these sensors. You would require your laptop and the connection cable, and obviously the seismic on the wall. That allows you to fully adjust and fully test the detector. And again, that works on both the seismics. Okay, if there's no other further questions, I'd certainly like to thank you for your time and attendance today. If you require any information, the numbers are still up on the screen here. Thank you again, and have a pleasant afternoon.